and welcome to our today's Cannabis Academy. I'm so excited to welcome all of these amazing people who are attending to our webinar because we did quite a long break, and I hope you missed us. You missed a bit, maybe me. Those who don't know me yet, my name is Alina Bonadonna, and I'm as always moderating sessions with brilliant speakers like we have today. So please, guys, warmly welcome our brilliant expert, Anu Bernier, speaking to us from Canada. Hi, Anu, how are you?
Good, Alina. Thank you. Thank you for the warm welcome.
Nice to see you, and thank you for accepting my invitation.
You're very welcome.
Okay, guys, just let us know with the magic button on the bottom left that you hear us well, see us well. Just drop us few reactions. Yes, I see first reactions. Yes, I hope, Anu, you see it now and you will see even more hearts. Yeah.
Great. I see them coming through.
Yeah. So afterwards, be ready to receive even more of them after your presentation. And
Oh, wow.
yeah, as always, my thanks to Nemis Technologies for supporting our small educational project to bring really valuable knowledge to people, to audience. And if you are ready, Anu, I'm just giving you your time, your stage, and enjoy.
Well, wonderful. Looks like participants are still joining in, but I'll get right to it.
Yes.
And well, thank you.
Okay, great. And as always, at the end, we have question answer session. So prepare your sharpest, the most curious questions to drop it in the chat window, and Anu will answer everything.
All right, I'll try my best.
Yeah.
Awesome. Well, good evening to the participants in the room, and good morning to those on the other side of the world. That's where I'm from. Uh, So my name is Anu Bernier. I am the director of Decoding Food Safety, and I'm here today to present the webinar on clarifying the fog between verification and validation. With over 15 years of industry experience, I really enjoy helping food businesses navigate the complexities of food safety, the regulatory requirements, and their needs. So I'm currently an accredited auditor for BRCGS and SQF, and also a lead instructor for FSPCA preventive controls for human food, and also an approved training partner for BRCGS and an SQF trainer. And as you can see, I really enjoy teaching and hence accepted Alina's invitation to present this webinar on one of my favorite topics. So we'll start off with the great confusion. So most teams treat these as synonyms, but they actually are not. Mixing them up creates a paper thin safety system. Many food safety programs are challenged during audits not because of missing records, but because of a fundamental misunderstanding between proof versus a dynamic check. This webinar aims to provide a clear technical framework for distinguishing between verification and validation within the GFSI umbrella. The learning objectives in today's webinar is to basically help you strengthen your food safety system by covering the definitions, which we'll be covering in the upcoming slides, and learning how to build an objective file using scientific literature, challenge studies, and in-plant data, and then move on to learning how to verify with precision, implement effective daily checks, the review of records and trend analysis, and also move on to covering a bit of safety culture. It's a Most of you must have been hearing about product safety culture and food safety and quality culture under your GFSI program. So we'll touch base a little bit about that and see how verification and validation can add value to that. So here are some definitions directly from the Codex Alimentarius International Food Standards. While the definitions are out here, what is validation? Validation focuses on the collection and evaluation of scientific, technical, and observational information to determine whether a proposed control measure is capable of achieving their desired outcome or target. It involves measuring performance against a desired outcome or target. And on the other hand, verification focuses on implementation of the procedures or process and measuring its effectiveness. So if you look at this as a big picture, we're starting with validation and how it transfers into verification and the loop back. So I often walk into facilities where the HACCP team and production team are often speaking two different languages. Your HACCP plan is your roadmap. It identifies the hazards and through validation tells us exactly what the speed limit needs to be to stay safe. For example, let's assume a specific temperature or a specific speed belt in your operations. Now, none of this would make sense. Like the roadmap is useless if no one is driving the car correctly. That's where your daily floor checks come in. These checks are your verification. Now, they are the objective evidence that proves you stayed on the road and followed the speed limits which are set by the HACCP team. Finally, look at the feedback loop. So all those records that are produced on a day-to-day basis, either production reviews them and comes back to the QA team, you do a verification. Just don't file them away. Use them for trend analysis and see whether if your system is still valid and acting as it intends to be, or if you need to revalidate your system based on the number of deviations that you're observing. Remember that HACCP is a living system, not a one-time event. So we'll move into different modules. We'll start with the validation module, followed by verification, and then look at the link between them. Now, validation is the science before the sign-off. If the science isn't solid, the sign-off is just a piece of paper. Now, think about it this way. Validation is a recipe, and verification is the tasting. You can follow a bad recipe perfectly well, and you'll still end up with a dish that no one can actually eat. So I often see perfect paperwork in facilities where the science is sometimes fundamentally flawed. I'm just going to present this as a hypothetical situation. Let's say that the HACCP plan says that the oven temperature must be at 64 degrees Celsius for killing salmonella, but the scientific evidence is actually 74 degrees Celsius for killing salmonella. You need to be able to, if you set this limit, you need to be able to provide evidence to the auditor or the inspector that's walking in to say, why did you pick 64? And that is where we will be covering more about validation. So when the auditor is coming into your facility, what they're looking for is answers on who told you these limits were safe. If you can't show them the science, the peer-reviewed journals, the challenge studies, or thermal mapping, then your signatures, no matter how neat they are, they don't provide the auditor with any confidence. So here are three pillars of validation that you can lean upon. Scientific is the published papers and peer-reviewed articles that are out there. Technical is the pillar where you perform activities on the production floor or in your facility. And challenge is also something that you perform at your facility. The technical and challenge go hand in hand, and I will cover more about these in the upcoming slides. So with the scientific pillar, it's about leveraging the experts who came before you. If you say you need a 3-log reduction of listeria, you must have a literature that proves your chosen method, be it heat, acid, or pressure. It's all scientifically capable of achieving that. You can lean on peer-reviewed journals, regulatory guidelines like FDA, Safe Harbor, or industry-recognized validation studies that are often published by your chosen GFSI schemes, whether it's FSSC, BRC, or SQF. And there's also another platform called International HACCP Alliance. They also publish a few articles on scientific publications. And in the age of information, also remember that not all sources are created equal. When validating a process, we aren't looking for a blog post or a best practice article. We are looking for peer-reviewed, reproducible science. National Library of Medicine, NIH, which is commonly known as, would be a great place for you to get scientific journals and scientific published papers. Please refer to these sources instead of just asking ChatGPT or Google. In the world of AI, you're welcome to speak with ChatGPT, Gemini, or whichever chosen AI of your choice, but make sure that you have the solid link in place. Make sure that you do get the scientific journal and make reference to it in your HACCP plan. Just telling an auditor, oh, because I saw it on a website or ChatGPT gave me the answer, that is not a sound answer at all. Instead, you can choose challenge studies by University of Nebraska or any university within your country. And moving on to the technical pillar, here, it's more about in-plant validation. Let's say the science is going to say that, 165 degree Fahrenheit is safe, but can your 1985-year-old oven is capable of maintaining the temperature consistently? That is where the technical portion comes in place. For those of you here, if you're using an oven, you might be familiar with this little measuring device called the MOLE, where they send in sensors through the oven, and at the end of the cycle, you're able to do a mapping and it shows the various temperature distribution. It's about ensuring that your scientific pillar isn't being undermined by a technical failure. Another example would be the use of pasteurizers in a dairy industry, where when you're installing the pasteurizer in your factory environment, the validation is done upon installation. And then every year you have an ongoing service where they come and verify that the temperatures are working in there as required. The third pillar is challenge studies. Now, think of challenge studies as an experiment. You will be challenging the system with a known fault and see if it works. For example, with sieving, to find the optimal sieve, you can introduce hazards you expect and find the optimal size of the sieve. And those challenge studies, it can also be done with biological and chemical hazards. For example, if you're trying to validate the effectiveness of cleaning to remove an allergen from one of your production line, you might have to play around with various chemical concentration to see what is the correct concentration of the chemical that needs to be used to effectively remove all residues of the allergen proteins. So to summarize the validation protocol, you start with aligning the science. You match the scientific documents to your reality. If the equipment can't hit the numbers or the SOP is outdated, you will need to update and replace them before you start again. This is about making sure that the foundations are solid. Then phase two, you're going to work on the execution where you're going to train your team. A validated plan is only as good as the person running it. So you've identified exactly what the team needs to know, and then you update all the training records to reflect the new safety limits. Then this is where you are moving the science into the hands of the operators. And finally, you set the guardrails. That is where verification comes into place. You decide right now how you will prove the plan is working daily. This is where the validation protocol ends and your daily compliance life begins. And apart from the initial validation at setup, there are several stages throughout the system where you might require a revalidation. If you bring in a new equipment or a new supplier or a new ingredient or even a food contact packaging material, or if there have been changes in scientific information, and if you've had consistently unsatisfactory lab results, then these would be triggers for you to revalidate your HACCP plan, your chosen CCP or your chosen preventive control or control point, depending on which country you're from. And these triggers must be closely monitored. And if you have a GFSI scheme and if the scheme dictates that you need annual validation, for instance, SQF talks about annual validation, then you will be required to do a annual validation of your entire HACCP plan. So keep these in mind for when you would need to do a revalidation. Moving on to the next module about verification. Now that you have established what you want to do, you're going to show how you're going to do it. That is where you're moving from the why to the how. If validation for the signs from our earlier slide, the actual temperature that is required is 74 to kill salmonella. So if the validation was the science that told us 74 degrees Celsius is the kill step for these meatballs, verification will be physical proof that we actually hit that number on the floor every day during the production. So you can do that verification in one of the two formats. You can either have a continuous temperature monitoring chart where the temperature gets documented throughout the production run and add a physical thermometer probe at XYZ frequency to verify the temperature. Now, it's the daily discipline of proving that our validated limits are being met every single batch, every single time. Whether you use a manual probe or a digital sensor, the goal is the same: instant, accurate proof of compliance. There are several methods of verification. Some of these methods must already be implemented at your facility. So we'll just look over some of them. Reviewing of records, the most common method of verification, and then you might have some sort of audits and product testing and environmental monitoring program testing, and then observation. So we'll cover each one of them in a bit of details. The dreaded records. I bet it's dreaded for both sides, both the production and QA, because production is working hard on making sure that all the records are done, and QA is also working hard at making sure that they're done as per the established schedule, and then verifying them also takes a lot of time. This is where I use the 1-7-30 rule. So verification isn't just signing a page, it's analyzing data. So 1 stands for every CCP record or the preventive control record must be reviewed within 24 hours. It's just best practice. Whenever possible, please try and do that. And then 7 is the weekly trend. Every week, take the time to look at the trends. Are we drifting towards the limit or are we drifting away from the limit? And 30 is the monthly. If you end up having monthly HACCP meetings or food safety meetings, it might be a good opportunity for you to present your CCP data to your management team to show them both the good and the bad instead of an annual management review. If you keep them up to speed with what is happening on an everyday basis, it will tie into the culture. Plus, it will also help demonstrate the management commitment part where they are interested, they are invested in the business. So you want to show them how the production facility is performing. On-site observations. You cannot manage what you do not see. Records tell you what happened. Observations tell you how it happened. This is about watching the process to ensure the SOP isn't just a document, but a habit. I always tell supervisors, don't just check the log. Watch the operator take the temperature. Are they cleaning the probe in between samples? Are they waiting for the reading to stabilize? If the observation doesn't match the SOP, the record is invalid. Then calibration plays the critical link. Calibration is the truth in your system. If your thermometer is off by 2 degrees, then the verification history is a lie. This is a critical link in accuracy. This includes everything from your metal detector to your X-ray, your scales that you use for verification of weights, water activity meter for testing the water activity in your products. There's lots more. I only had room to put enough pictures here, but a pH meter, ATP meter, anything, any measuring device that is used in your facility must be calibrated. And the calibration sticker on those measuring devices and equipment is key as well. And for your thermometer, make sure that you have at least one master thermometer in your facility that is traceable to a national industry standard like NIST, such that you can such that you can perform the verification of the calibration of all the other thermometers against the master NIST thermometer. And the other method of verification is audits. I'm sure most of you must be going through your third-party audits under your chosen GFSI scheme. And as part of it, you might be conducting internal audits. So that is a very good method for verification of your entire food safety plan. Along with that, you must be doing your daily inspections or weekly inspections for GMP. That's also a method of verification of your system. And in addition to that, you would be using external audits of suppliers. So when you have an approved supply program and you have a whole list of suppliers, you could either perform audits yourself at their facility, as long as you're qualified, or use a third-party audit report that is provided by your supplier to ensure that they're meeting the specified requirements to provide you with quality ingredients that meets your specific requirements. And reviewing the corrective actions within your own program also is a form of verification. For example, as part of the CCP verification, to establish if the agreed actions were carried out as specified in the HACCP plan, could also highlight areas where the system is not functioning as planned, i.e., identifying problems. And when you review your customer complaints, that also is a part of verification or a form of verification. They provide information which can indicate either success, failure, or inadequacy of controls implemented. Example, a large number of hair complaints could indicate that the controls for hair covering is actually not achieving the desired outcome due to either improper application or inadequacy of the protective hair covering, etc. Likewise, a lack of metal complaints could indicate that the system implemented to control metal is producing the desired outcome. So that is also a form of verification. So hence, to summarize the audits, it is not just your third-party audit or the internal audit, but it's auditing various components within your food safety system, such as the review of the customer complaints, your CAPA trends, and your suppliers. And one of the last method of verification that I wish to cover is testing. This I would consider is our final exam. Everything else we have done so far is about checking records, watching staff, calibrating tools, which are meant to prevent contamination. Verification testing, like listeria swabbing or finished product testing, proves it worked. We're moving away from the test and hold towards the search and destroy. We use environmental monitoring program to find where pathogens might be hiding before they ever touch the food. This is the ultimate objective evidence that our sanitation and GMPs are effective. And then comes the question of the frequency. Like, okay, great, we have a verification schedule, but at what frequency should we be testing? It is kind of a $1 million question because it's not one size fits all approach. Determining the frequency checks of your CCP and preventive controls, it must be site-specific. Frequency is a direct reflection of risk. If a CCP has a high likelihood of drifting, or if the hazard is severe, like botulism or a metal contamination, your verification frequency should be a bit tighter. And on the other hand, if your process is highly stable and the hazard is a low risk, you can justify a longer interval. Higher risk is equal to higher frequency, and lower risk is justified confidence. For example, if you produce 10,000 units an hour, a once a shift check is a high risk because a failure could affect 80,000 units. Frequency should align with your clean breakpoints. Don't let your frequency be a guess. Make sure that you document the logic. Statistical data analysis and historical data is very important. So if an auditor is going to ask you like, hey, so how did you choose your frequency of metal detection check at every 4 hours? Rather than just saying, oh, it's based on industry standard, show them some sort of an evidence. We chose a 4-hour interval because our historical data shows a 0.01% deviation rate, and it aligns with our sanitation cycle. By having something like this, you're basically winning the argument even before it starts. So moving on to the next module about the strategic link, how is the validation and verification coming together? If you're ever in an audit and you freeze up on these definitions, remember this chart. Validation is the science and verification is the signature. Pay attention to the frequency distinction. Ideally, validation must be done before the process starts. That's even before you set up your factory. But again, I'm sure most of you are here where the factory has been in operation for the last 100 years, 150 years. That's okay. If the validation was done at the start, just don't let it sit. Periodically review it at XYZ frequency. If your chosen GFSI scheme requires an annual validation, you don't have to redo the entire validation. Review it against your scientific journals, and make sure that nothing has changed and have that documented. So with regards to the frequency distinction, validation before the process starts and annually where required, and verification is ongoing, whether you choose it daily, hourly, per batch, weekly, whatever you've chosen based on your CCP. Now, the other important thing between the validation and verification is the goal. The goal of validation is to prove the plan can work, and verification is to prove that the plan is working. Now, connecting the dots between validation and verification. I want to see that your verification parameters are actually slightly stricter than your validation. For instance, if your validation says 74 degrees Celsius for killing the salmonella as the kill step, your verification goal should at least be at 75 degrees Celsius. Ideally, we would call this the operating limit. It's a whole other webinar to talk about critical limits and operating limits. But to connect the dots, you set your validation limits, and then you set up SOPs and work instructions, and you train your operator on how to do it, and tell them that for verification, you are going to take the internal temperature of each meatball batch at the end of the cook cycle, and you decide your frequency based on your risk assessment, whether you're going to do it every 15 minutes, every hour, and have that portion documented. Now, if you change a parameter, so this is for the production team. So let's assume somebody hired a executive chef in the role of a production employee, and the chef comes in and says, ooh, you're cooking meatballs at 74 degrees Celsius? That must be dry. I cook it at 70 degrees Celsius in my restaurant. It might work for him at a restaurant, but that is not proved by science, because in a manufacturing facility, you need to have evidence. So if he decides to change that, he needs to come back to the HACCP team And you need to justify, if you're going to change it to 70 degrees Celsius, you need to justify with science, why did you do 70 degrees Celsius? Are you able to show that salmonella is killed at 70 degrees Celsius with an extended contact time or whatever it is? But the reason I gave this example is basically to show that you can't move the scoreboards without checking the rules of the game. So the scoreboard is established during the validation, and then the verification is just to make sure that you constantly get objective evidence to demonstrate that that number is met. So for the QA managers in the room, this is how you explain your value to the production team. You aren't just giving them more paperwork, you're giving them the validated parameters they need to stay safe and profitable. Here is a slide where I want to share some of the common audit nonconformances that I've often seen during my audit time. There are lots, but I just chose a few examples to share with. Um, when I've asked for a validation report for the X-ray or the metal detector, I've often been given the calibration report. That is not a validation. Confusing accuracy with capability is a classic trap. Calibration proves the machine is reading accurately. Verification, which is verification, and validation proves that the machine is capable of detecting your critical limit, whether it's 1.5 mm ferrous or non-ferrous shard in your specific product, which is the capability. Accuracy is worthless if the settings aren't scientifically capable of finding the hazard. Ideally, when you have your X-ray or metal detector installed in your facility, your service providers must complete a validation on the equipment, which they do. Just make sure that you get that report from them. Make sure that during that validation process, they have tested different product categories, product groups with various sizes to demonstrate that why did you pick a 2.0 mm versus a 1.5 mm? Did you get a 100% rejection rate or not? So those are the parameters an auditor is looking for in the validation report. And I've had an incident where when I asked for a CIP validation report, they gave me the monthly supplier, the chemical supplier verification report. What your supplier is doing on a monthly basis is not validating whether your CIP is working effectively. He's just verifying that if the chemicals are actually at the right concentration. With a CIP validation, it's again done at installation. I want to see what is the chosen temperature, what is the contact time, what is the flow rate, what concentration of detergents are being used. And all of this would have been done during the installation and should be as part of the CIP validation report. Can also be a part of your FAT file. And then when I asked for oven validation, something that we covered in the previous slides, what I've been given is your daily temperature check logs. That is not the validation report. Again, record versus proof. So validation is the thermal mapping of that oven to prove that there are no cold spots where pathogens could survive, whereas your daily temperature check logs is an act of verification. And this one was a very cute facility where when I did ask for the scientific evidence of why are you using parasitic acid at so-and-so concentration for your grapes, they showed me a scientific paper that showed the evidence for melons instead of grapes. So please make sure that when you do your literature search and grab your evidence that it is product specific. So overall, just making sure that you understand that validation is not verification. So to bridge the gaps, compliance is what happens when I walk into your facility with a clipboard. And culture is what happens at 3 a.m. when no one is looking. Bridging this gap means moving verification out of the QA office and on to the floor. When an operator understands the validation, which is the science behind their task, they aren't just checking a box. they are protecting a consumer. A strong food safety culture means every employee feels like an auditor. I often can sense a good food safety culture within a few minutes walking onto a floor. It's in how basically the staff speaks about their CCPs. If they say, I have to sign this document for QA, then that is compliance. If they say, I'm verifying this so our customers stay safe, that's culture. So hopefully you get an opportunity to move your production floor from compliance to culture. And if you're already there, job well done. Keep it up. We can also start using technology, the modern tools out there. We are now moving away from history-based food safety. The old school verification told us that the products were safe 3 days ago. But with modern tools like rapid diagnostics from NEMIS, it gives us real-time verification. Elimination of the lag, the technology removes the wait time. If we find a pathogen footprint now, we can intervene now. This isn't just a safer, it's more profitable because it prevents large scale holds and recalls. Data integrity, digital tools don't have bad handwriting. Hey, I'm guilty of that too. And they don't forget to sign a log. All the QA techs and QC techs out there, not undermining your performance at all. It is a hard job, and there's so much documentation we do every day. So, leveraging technology just helps everything to be more in an electronic version and not be in a situation in an audit where the QA manager is reviewing a record and they're like, oh, I cannot see if this is a 3 or a 5, things like that. So, take the opportunity to see if you can improve what you already have in place by using modern tools. And the golden rule is the proof. If it isn't documented, it didn't happen. If it's documented incorrectly, it's a non-conformance. So to make your paperwork auditor-proof, you need to follow the ALCOA principles. If you haven't heard of this terminology, attributable, legible, contemporaneous, original, and accurate. We all look for honesty over perfection. As an auditor, if I'm going to walk in and see 12 months worth of records which are immaculate, I'm not going to be impressed. I'm rather going to be suspicious. So just make sure that your records are original. If a mistake is made, please follow the best industry practice of striking, initialing, and documenting the correct information rather than using whiteouts and scratches. And also make sure that the records are contemporaneous. If I walk in at 1 p.m. to the production floor, and if I see that the CCP checks have been completed for up till 4 p.m., that is a failure of your system. And if you were in a GFSI audit, you failed the audit right there. Original, authentic records are also the foundation of your food safety plan. And make sure that all records are attributable such that you have information on who did the test with some initials and that they're also legible. So moving on to the end of the seminar, where we're going to talk about how can you actually implement the verification and validation at your facility. I'll walk you through a summary checklist. If you plan on doing a screenshot, this is your screenshot moment. If you can answer yes to all 10 criterias, you are not just audit ready any given day, you're actually running a truly safe facility. So what are these 10 different parameters? So the why test. Pick one CCP and ask the operator, do you know why we hit the specific temperature or the limit, whatever your CCP is? If they don't mention the science behind it, then you have a validation communication gap. So work on that. The paper trail. Does every CCP summary, such as your, let's say, the Form 10, where you have the CCP documented, or your CCP procedure, just make sure that it makes reference to the validation study or the scientific journal that you chose. If it's not there, take a moment to make that reference or add it in there. The lag time audit. Look at your most recent micro results. How many days passed between the swab and the results? Can we shorten this with instant verification tools? If so, you have an opportunity for improvement. If you already have great tools, that is awesome. Job well done. 4, independent review of records. Trust me, a fresh set of eyes often adds so much more value. Check the last 5 days of CCP logs and see whether the verification signature is done by the supervisor or by the person that's performing the task themselves. 5, calibration check. Are the tools used for the verification of your chosen CCP currently within their calibration window? 6, the change log. Have you changed a supplier of a raw material? Have you brought in a new equipment? If so, has the HACCP plan been revalidated? Check that. Number 6, SOP versus reality. Go and observe a sanitation tech for about 10 minutes. Are they following the validated contact time for the chemical, or are they rinsing it too early? And then the missed check protocol. Does your verification log clearly show what happens when a limit is not met? Do you have the corrective actions documented? And move on to your 9th checkpoint, visual evidence. Are there visual aids on the floor, such as your visual aids, your cheat sheets, or some sort of a product spec that basically helps staff verify their own work in real time? And lastly, the fresh eyes walk. When was the last time someone from outside the QA department, like maintenance or production, or even R&D, performed a verification audit? So try this summary checklist. And with that, I want to mention that knowledge without action is just overhead. So I want to take this opportunity to raise a friendly challenge to each one of you to take 3 specific steps in the next 48 hours. I call it the 48-hour challenge. Hour 1, brief your leadership team on the verification and validation gap. Just summarize this webinar to them. And then in hour 24, perform 1 floor walk using the 10-point checklist. And then within the hour 48, identify 1 CCP that needs a scientific pillar update. Now, don't try to overhaul your entire HACCP plan overnight. Start by walking the floor with fresh eyes and identify just 1 area where your verification isn't meeting your validated standards. Small, consistent wins are what builds a world-class safety culture. And the future of food safety, just taking a moment to speak about the lag time problem, which I do see consistently with my clients as well as when I go to audit. Traditionally, verification like micro testing has a 2 to 5 day lag. By the time you get a fail, the product is already out in the supply chain. That is, if you don't do a positive release program. Modern technology like NEMIS, rapid diagnostics provided by NEMIS, it allows for real-time verification. We are moving away from history-based food safety to real-time assurance. And we no longer have to wait for the lab to tell us if we were safe yesterday. So there are some nice methods of verification that you can use to support your food safety plan. If you remember nothing else from today, remember this. Validation is your promise to the customer that your process can work. Verification is your proof to the auditor that it did work. By connecting these two, you aren't just passing an audit, you're protecting your facility, your brand, and your consumers. So science first, followed by the human factor where you're training them, and then verification. Use real-time data, and then audit proofing your entire food safety plan following the ALCOA acronym. And with that, I thank you for your time, and I'm opening the floor for Q&A.
Thank you so much, Anu. And I don't see reactions, guys. Where are your hearts, claps? Because it was so, so, so important and valuable webinar. Yes, yes, this charming lady deserves. And yeah, while we are waiting for the first questions, I would ask you, Anu, maybe can you summarize what are the most important certifications or education, online, offline, doesn't matter, for people to obtain to become expert and define better validation, verification, and be the one who bring the knowledge and change the system?
Absolutely. Great question. And I should have given this as a disclaimer. Verification and validation actually, it's a very intense topic, and there are trainings out there, which is actually a day-long training, which covers more in depth about validation protocol and how do you design a validation study and other things. So I tried my best to summarize everything within a 45-minute presentation. But to answer your question, Alina, there is a one-day training provided by BRCGS on verification and validation. And if folks out here are interested in obtaining that training, they can reach out to you or me. On the next slide, I'll present the contact information. And I do have a few sessions for BRCGS verification and validation courses coming up. And if anybody out here is also aiming to become a BRCGS professional, those courses, the accredited courses, will help you collect your points to become a BRCGS professional as well.
Yeah, and there is some extra disclaimer from my side that we are planning to have 3-day course with Anu in October, right?
Correct.
Yeah,
That
can you
course,
tell more about it, huh?
absolutely. So the upcoming course in October is an FSPCA Preventive Controls for Human Food version 2.0. So if your manufacturing facility is based out of the US or anywhere outside the world, and if you are exporting products to the US, as long as if you have an FDA registration, somebody in your facility is required to be a PCQI, which is a preventive control qualified individual. Taking this course is one way to meet that requirement. And there has been significant changes in the curriculum from version 1.2 to 2.0. So this course will significantly help you update all the requirements and make sure that you are meeting the regulatory requirements in compliance.
Yeah, and you guys have a brilliant opportunity to get discounted rate per 20% off. Just use the promo code I just shared and be the first who can get the first hottest spots, because if I'm not mistaken, we have only 10 spots left, right? So that's
That
why,
is correct.
yeah,
Yes.
great. So there is a question. Can you share the 10-point checklist you mentioned in the summary slide? So maybe we can repeat it again, and then afterwards, you just, Janelle, you just DM me, and I will share slides.
Absolutely. Sorry, did you want me to go back to the slide and repeat it?
Yeah, I think it would be nice to summarize kind of again.
For sure.
So maybe somebody can take a screenshot.
Yes,
Yeah,
I did say that this is a screenshot moment, but thank you for that question. I did want to put it out there on my last slide that if you guys send me an email, I'll be more than happy to share this checklist with more details, because this was just a simple checklist, but I spoke about everything in my presentation. But when I share the checklist with you, it will have more information. It's basically a two-page where it has what I want you to look at so that you can make sure that your food safety plan is actually intact.
great. And um, in terms of, if we are talking about policies, what policies, on your opinion, should food production facilities implement to minimize the risk of pathogen detection, pathogen contamination, sorry?
It will all start with the environmental monitoring program. So that is the bread and butter. of any facility,
Yeah.
because nobody wants pathogen in their facility. And I actually really I read through the NEMIS, the diagnostic rapid tests, and it's actually a very good way. We are talking about seek and destroy, which is very crucial, because if you have an environmental monitoring program in your facility, this is for everybody in this webinar, and you're like, okay, we are low risk, we're only swabbing for salmonella once a year, XYZ, and we're consistently getting negative, challenge your program. Challenge it. If you're simply just swabbing zone 4 in one area, challenge it. Go deeper and seek and destroy it, because once it is in your facility, then it's hard work. It's going to cost you millions, if not less, to destroy that from your production floor. And another misconception is also listeria. Everybody thinks listeria is only for a wet and cold place. If you are a dry facility and if you have a sanitation bay where there is a drain, do not discount it for it being a possible harborage spot for listeria. So take a look at your environmental monitoring program. And to answer your question, Alina, the environmental monitoring program is the backbone of making sure that there are no pathogens in the facility. And if folks on this webinar, if you haven't already seen the NEMIS webpage, there is a zone 1, 2, 3, 4 breakdown, and it kind of gives a brief overview of what is zone 1, how do you define zone 2, and zone 3 and 4. And there is also an FDA guideline on listeria swabbing, which gives you a good source of information on how many samples to be taken, at what frequency, how soon should those be tested, within 24 hours or 48 hours, and also gives you a bit more information on commodity specific requirements as well. So take some time and explore those guidelines from FDA and the NEMIS website, which outlines the zones. And if you are getting consistently negative answers, make sure that you expand it and refurbish your environmental monitoring program. And if you are getting some hits, let's say it's even a non-pathogenic strain of listeria, don't ignore it. Don't just do a deep clean and move on. Try to alternate your chemicals, because biofilm is a new hurdle that we're all dealing with these days. So reach out to your chemical suppliers and try and get answers to address them.
Yeah, and maybe there is another question which is quite often and commonly repeated. Can you please describe the difference between hazard and risk in the context of food safety? So,
Hazard and risk.
yeah.
You're going to make me teach my 2-day HACCP class in less than 5 minutes.
Yeah.
I'll try my best without confusing. Um, so hazard is going to be okay, I'm just trying to pick my words wisely so I don't confuse the group here. So we all know that there are various type of hazards, which is your biological, chemical, physical, and allergens and radiological, and they're just various categories. So hazard exists. They inherently exist in any of these forms. Risk is the assessment of the hazard. So hopefully that's a simple one-liner. So the hazards exist no matter what. They can be inherent or they can be man-made during your process step. And risk is the assessment of the hazard. That is where you would take the hazard, you evaluate it. So risk assessment is an evaluation of the hazard. You evaluate it for the likelihood of its occurrence and the severity of the consequences. And then you give it a risk level and say that, okay, based on my assessment of the hazard, my risk level is low, and I'm going to control it with so and so programs. Okay, based on my risk assessment, my hazard is medium or high, and hence my risk level is high, and I've decided to call it a CCP because it is utmost important that it needs to be addressed with a critical control point measure. So hopefully that gave you a clear understanding of hazard and risk.
Yes, yes, because that's something that is always popped up during all of our webinars, and it's good always to repeat it and encourage people to submit to your course.
Absolutely, absolutely. It was a very layman explanation to keep it simple, but you are right. It's a very it's very confusing for somebody that's starting out in the career, especially.
Yeah, and maybe as a kind of summary for today, like you mentioned, there is one more question also. Can you share examples of scientific sources for CIP validation?
Mm, uh, Great question. Usually, um, CIP validation would come from your chemical supplier. I can I can check for some published papers. I will have to get back to you on that. And I think Alina might have the email. But
Yeah,
if you go to, I'm just going to try this. Where's my presentation? I'm going to go back to this page right here where I shared some sources. Um, Whoops. Going all the way back to the front. So right here, the National Library of Medicine, if you go to this website and even ask Google Scholar about CIP validation and pick your commodity. Let's say if you're a beverage, put your pH range in the search on there and see if there is a specific paper for CIP validation there. And also if you are, let's say, dairy or egg, put all your product characteristics on the Google Scholar search or on the NIH website. And also the FDA Safe Harbor over here, this is an open link. I just put a snip of this, but this is actually a link where there is a red book and there's a lot of information out here. And you can go and search specifically for your commodity out there. Hopefully that helps.
yeah. Okay, anyway, I will share with you the email of this person. So if you want after to, you can chat.
Great.
And the question I wanted to ask, like kind of summary, while I don't have more of questions here, you mentioned AI technologies, like different tools, etc. How do you see this influence of AI in food safety and the implementation of new tools?
It's a mixed feelings. It is both good and bad. I'm not against AI. It's okay if you want to use AI. I touch based on it very briefly. But I'm just very disappointed often when I go to sites and they say, "Oh, I got this from ChatGPT." I was like, "That's incorrect information." Like I also use AI, don't get me wrong, but you should know your information. That's where using the Perplexity is a good AI. I'm not here to say which AI is better over the other, but make sure that whatever information AI is giving you, try to go to the link and see that is this actually a peer-reviewed article? Is this actually a scientific paper? Is this coming from a government source? Is this coming from government of New Zealand or FDA or Canadian Food Inspection Agency or Health Canada? Make sure that the information that you get from AI is not just random information. You need to have the scientific evidence to support that claim. So, why I have mixed feelings is somebody that is knowledgeable and know what they are doing. They're, for example, the meatball example, the case study that I used here. I tried chatting with ChatGPT on purpose, and it's like, oh, yes, 73, 72 degrees Celsius is all right. And I'm like, no, it's not. Show me the scientific evidence. And then it writes back saying, oh, I don't have answers for that. So please make sure that if you're using AI, use it as a starting step and then go and get the evidence to support the claim using some of the sources that I shared on that website. or that slide.
Yeah, and basically it applies to all industries, I would say. So
Absolutely. Yes.
there is still one more question, so I hope you have a few more minutes. In the example cited, peracetic acid conc for grapes or melons. If the conc for melons was a worst case scenario, I'm thinking cantaloupe reeds, would that be an acceptable explanation for why the conc was chosen?
Can you read the mid part again? So
Um,
if it's the worst case scenario,
if it's the worst case scenario, would that be an acceptable explanation for why that conc was chosen?
great question, but unfortunately, it depends on,
Concentration.
yeah,
Yeah.
I understood concentration. That's fine. So in this situation, unfortunately, the answer will be a no. The reason being, or I should rather take my word back. It depends. If in my example, did I use grapes or apples? I said grapes. Okay. In the situation of grapes, the answer is going to be no. The reason being, in a melon situation, you are removing the skins out and you have a higher concentration. And in the situation of the grapes, you are not removing the skin and you have the potential of introducing a potential chemical hazard by choosing a higher concentration. If you take the example of an apple instead, and if you want to justify the concentration of the melons for the same as apples, it may work if you remove the skin of the apple and justify that that's how your production system works and you don't have any SKUs that uses apples with skin on. But there are published articles out there that clearly outline concentration requirements for various categories of fruits and vegetables. And higher chemical concentration often is a misconception that, oh, more the chemical, the cleaner it is. Unfortunately, no, you will just be introducing a chemical hazard. So be very cautious of the scientific evidence that's going to justify that.
Yeah. Thank you so much, Anu. And I hope it was like super, super, super great answer. I do believe so. And yeah, guys, unfortunately, we have to close our session because it's already time to leave. And yeah, Anu, if you want to summarize somehow, like in few words, the outcome of this presentation, what you want to, what you want people to take up from this session, you're welcome.
Well, honestly, I want to thank you all for giving me the opportunity to present. I really enjoy teaching, and I'm very impressed with the turnout from all over the world. You guys are doing a great job. I do want to say that. Anybody in the food industry, thank you for making sure that the food that the public eat out there is safe. I have two little ones, and every time I go to a grocery store, I educate them on various things. So thank you all for doing what you're doing. Thank you for joining webinars like this to educate yourself and keep abreast with newer technologies. And also, from this webinar, verification and validation, it's a very confusing topic. 18 years ago, if you spoke to me, I would have been interchanging the words as well. So take your time, learn more. There are training available for giving you an in-depth lesson on verification and validation. And keep watching Nemis Space. There are more trainings coming up. If any one of you are in the SQF versions, we have SQF Edition 10 training coming up. We have both the 2-day training as well as the half-day conversion training. So Alina will be publishing them. And we have the FSPCA training coming up. And if you're interested in anything else, there are lots of trainings out there. Feel free to explore my website and also reach out to Alina, and we will send you that 10-point checklist to you via email. Thank you all. Thank you for staying up late and joining in early. I appreciate your participation.
Thank you all again from my side, and see you next time already in Milan. Hope that some of you will join and we see each other in person. Bye bye.